Test, test.
For the Q&A session. Są tutaj jeszcze 2 miejsca z przodu, jakby ktoś chciał. Zapraszamy. Okay, let's start. This presentation will be held in English. Leandro Salemi and Miłosz Bolibrzuch will be talking about typing in Python, so probably a little bit of good software engineering practices in data science world. So please welcome both our speakers and yeah.
All right, thank you so much. So yeah, today we're gonna talk to you a little bit about type hinting and validation in Python. Just a super brief intro about us. We're both data scientists at Twigio, which is a full-service growth agency, and growth is just a fancy term for a marketing agency that works with a lot of startups and scale-ups, and some of which you can see here on the picture. So just to put some context on like why we specifically care and why we find these concepts useful, let me just briefly talk about how it is to do data science at a marketing agency. So firstly, obviously we're working with multiple clients. So we're actually mostly working on fairly similar problems like measuring the efficiency of marketing and so forth, but we have vastly different data sets to work with, and the business logic can change very drastically from one client to another, right? We have a streaming service and then a subscription app, different stages of growth, all that kind of things. It varies a lot. We're a small team, so we're not like assigned to specific accounts, aka clients. We have to do a lot of jumping in and out. We have many time-limited opportunities, so it would often be the case that, let's say, we have a client that the marketers tell us, oh yeah, they might be able to spend more with us, and we obviously get paid the more the client spend in most cases, but like they need just a little data-driven persuasion, right? And they would spend next month, so we have to jump in and do something right now, or else the opportunity is gone. And the same on the other side, maybe there's a potential budget cut, and if we can prove the value of some marketing channel in time, we can avoid it. So yeah, all that means that we need to have a really robust and flexible toolkit to be able to drive that client growth with the team that we have. And that brings us to the topic of the talk. So that's why we care about validation and type hinting. But before we dive in deeper into the best practices and all the cool stuff, let me just go through like a very brief definition. So what does validation mean? On the baseline, it's basically all about checking that the variables that you're passing satisfy some types of requirements. So it could be either like, is it a float, or it could be that it has a specific value. Super simple example, let's say we have a function that squares a number, and we have a requirement that the number has to be an integer. And here, very important to stress that this is like an arbitrary requirement, right? We can square non-integers, but you know, assume that maybe it's business logic, maybe for whatever reason we want to do this specific thing. So ideally, this should work if we put an integer. If we put a string, we would like it to not work. But we don't get that for free in Python in all cases. So maybe we can do something very basic, like just put an if statement there, raise an error if it's not an integer. However, we're going to talk about some cooler ways to achieve this today. And yeah, for data science specifically, we're obviously handling a lot of data. So We might be handling n-dimensional array, data frame, series, all kinds of stuff. We might have an example requirement that the temperature column needs to be a float and it can't be null. So then this would be a valid data set, and then this would be an invalid data set, and we would like it to, if it passes through our pipeline, to raise an error or at least a warning. So yeah, that's today's goal. We're gonna try to convince you, or at least raise your interest in some easily maintainable, scalable, and declarative ways of performing these types of validations, and both on variables and data. And with that, I'm gonna pass it over to Leandro to go a lot deeper.
Yeah, thank you very much, Miłosz. So I guess everyone here is somehow familiar with Python. Python is a really amazing tool. I'm myself a big fan, and there's a lot of things to say about Python. So today, the talk is really around the fact that Python is a dynamically typed language. So Python in itself doesn't care if x, any kind of variable, is an integer, a float, or a string. And it's really nice because it's really flexible, but it can be like a bit dangerous sometimes. So the dynamically typed characteristic of Python is just the fact that you can assign anything at any time, and if the code works on that type, it will just execute without raising anything, any problem. Like here, you can see I have my var, like data submit a string, and my var that is also an integer just after, and my function works with both type, and things will work perfectly. And sometimes you want that, but sometimes you don't want that behavior. And Python also is an interpreted language, so there is no compilation. So it means there is no like check step before you execute the code, right? But it's really nice, of course, because it's extremely fast to prototype and execute and try code. And that's one of the reasons why Python is so popular right now in a lot of different domains, and especially in data science and machine learning. So yeah, so this dynamic behavior is really a double-edged sword, and we're going to see today how we can dull one edge of that sword. So let's start with type hinting. So type hinting here is everything about like Python itself, like everything is in the standard library, so there is no additional library you will need to install. It comes with the Python installation. And type hinting was introduced in PEP 484. So PEP is all like this Python enhancement proposal that people write, like the community writes to improve Python. And every version of Python, we include some new PEPs, and then Python evolves and have more capabilities. So what does it look like? Well, when you write a basic Python function, that's probably how you would do it, right? You just write a function, you declare it, you write the core of the function, and then you call it. And you can see at the bottom here, like when I call the function, actually my ID is nice because it can show me what is the return type of the function. So nowadays they are really smart, they can detect that automatically. But we can do much better. So we can introduce type hints, and you see the change is really minimalistic. It's just you specify that name should be a string, and that the return type of the function is a string. And now, when I call the function, it's pretty clear what I should pass to this function. And you see here, of course, this example is really simplistic, but when you have functions or classes that you need to instantiate with like 5, 6, 10 arguments, then it's really helpful to see those things. And of course, if you want to be, let's say, la crème de la crème of the programmers, you should include documentation, and you should always think about it. And then like your ID is even going to show more things. Like there is a big thing to understand about type hints is that everything is optional. Python doesn't check anything from you, like doesn't check anything for you. Python is, and actually it's written in that PEP, Python is a dynamically typed language. It will remain forever and ever, as long as we exist. And there is absolutely no desire from the Python developer to impose any kind of like static typing thing. If you really need static typing, you should not use Python. Yes, so, sorry. So the typing library, so it's a library that comes with Python installations. You can just import it, just like you would import any kind of other thing in Python. So from typing, and then you can import a bunch of different things. And they have their own meaning. So here I'm showing a lot of different examples. So here is my function. and I do something cool in it. And I didn't specify anything here, so of course this code is wrong. I need to replace those interrogation by something. So if x can be an integer, a float, or a string, then you can use a union. If one of your component of the union is none, you can use union as you did before, but you can also use optional. So just this is like a synonym. If you need to pass a dictionary that has a string to float mapping, you can write it in this way, like a list of floats, this way, like a callable. So a callable, like it can be a function, can be an object whose class implements the call method. Then you can actually specify really like, this is really nice. Look, you can specify what the function expects as inputs, so an integer and a list of string, and what it will return. So it is a really verbose way of writing what kind of callable you need to pass. And if it's any type, because sometimes you just have a function that is really versatile, and maybe like then it's a choice, then you can also pass any to really specify, oh, here you can just do whatever you want. So because typing is part of the standard library, of course, depending on Python version, you might have access to some capabilities or not. And as far as this library exists, like the most important one are always there. But if you use an older version of Python, let's say 3.8, and you need a really new thing from the typing library, maybe it's not yet there, you can use the typing extensions that you need to install with pip, and it will help you with backward compatibility. So you'll be able to use newer Python capabilities in the older one. So type hinting integrates really well with documentation, and in fact is part of documentation because it's not something that is executed by Python itself. It's just some piece of text that you write to make your code really explicit. And because it is part of the standard Python, it has become a standard. So tools that work with that are really like plethorous. And Sphinx, that is a really great documentation tool if you want to write nice documentation, like read the doc style documentation, like integrates with type hinting. And you can see here, I only specify in my function definition the types, and in my web interface where I have my documentation stored, like the type is really like written in every single place. So it's really clear and neat. Okay, so that's for the first part of this talk about type hinting. So the key takeaway I would like you to remember today, it is that type hinting is all about specifying what a variable should be. And I really insist on this should be, because it's never enforced by Python, so you can mess it up. It is a form of documentation, so really think about it that way. Extremely useful for collaboration. So when you want to share code with others, I'm pretty sure if you have collaborated with people, you've read some functions or classes and you were like, what the heck is going on there? I don't understand how I should use it. Well, type hinting is going to be like a really nice thing to add on your code to improve readability. And don't forget that you're your first collaborator. So you will have to read the code you wrote like 1 year ago or so, and you will have forgotten what you did there. So type hinting is really going to help. So it is optional. There is no runtime effect. Think about it as like text. So you can write it that way. So x is an integer equal 1. But you can also mess it up. So this would execute perfectly, and Python will not raise any warning or error, right? Your IDE will probably do. So if you use like, I don't know, VS Code or PyCharm, doesn't matter. Like your IDE will probably like underline this and tell you, hey, you're doing something weird there. But those are just hints, so nothing is enforced. And it is really mature with a rich ecosystem. So the PEP I showed you before, I think is like 10 years ago or so. So it's really, really mature. The Python typing library has got you covered for most of the things, and it integrates really well with third-party tools and third-party validation libraries. And it's quite easy to pick up, so it's not too much effort from your side. And really, the effort to lifespan save ratio is really, really worth it. It's going to help you like work in a more peaceful mindset. So yeah, let's now talk about validation. And validation, because Python, of course, is a dynamic programming language, we need to install third-party libraries. So just a quick refresher on data classes before we go. So data classes is just a nice way to write classes. Just want to be sure that everyone is aware that this exists first. So when you write a normal class, that's how you would do it, right? You write the constructor of the class, usually like this. And here is like an example class that stores like the specification of a regressor. So the features, the order of the polynomial regression, for instance, and the scoring you want to apply. And you define the class name, define the init signature, and you set the attributes. Pretty simple. Now, you can use something, and this is pure Python, like no extra libraries, something called data class. that will essentially remove a lot of boilerplate code. So you decorate your class with this data class keyword, and then you declare your attributes. And the data class will create this init for you. And actually, it will do much more than that, but I won't go into detail. If you have never heard about that, I really recommend that you have a look. So again, no validation here. This is pure standard Python. So now, the core of the talk, validation. So to use validation, you will need to use extra tools. And the two tools that are really like the most famous for validation one is called attrs, and the other one is called Pydantic. And you can use both. It's never like a one or the other choice. Both are valid, and they have slightly different way of working. And depending on your personal taste or your problem, you might want to use one or another. So let's look first at attrs. So you can see attrs like a supercharged Python data class module. Actually, like attrs is older than data class, and data class is inspired by attrs. From their website, it's trusted by NASA for Mars mission since 2020. So you can see that validation is a really important thing in like a critical application, like flying to space, for instance. It's based on decorators, and it is not opinionated. So this is really a good thing about attrs. I really like it. It is that it does exactly what you tell attrs to do. It doesn't assume anything. So you need to be a bit more verbose when you use it, but then you have a bit more, like let's say, I wouldn't say control, but like you're a bit more of a peace of mind that you know exactly what it's doing. So you see the way you write the class itself, you declare it, is really similar to a data class, and then you define this attrs.field element. So you declare the attributes, similar to data class, with of course support for type hinting. And then within this attrs.field, you can declare the validation logic. And a lot of validation logic comes baked in with attrs, and you can implement your own, and I will show you how you can implement your own in a moment. But this is like how you would do it. And then you can also possibly declare default values. So let's see how it works. So this is the same piece of code as before, and I'm just going to use it. So here I'm passing a set of arguments which are all valid. So nothing will happen, just the code will execute. And you can actually see that attrs actually represent my object in a really nice way, like human readable. I didn't implement anything. Attrs did that for me, and data class also do that for you. If you try to pass something wrong, like here, you see like the quarks, the feature has an integer, should be a list of strings. Attrs will raise an error, and the error will be quite verbose and quite nice to understand from the developer side. So we can really pinpoint where the problem is. So you can do something really similar with Pydantic, but it is a bit of a different tool. So Pydantic is really popular with a rising number of users lately, quite fast development. I'm really amazed by it. It has a huge and impressive ecosystem around it. It's becoming more and more like kind of a standard. It integrates really well with type hinting and kind of like takes type hinting to the next level. And it's based on inheritance, so slightly different than the decorator-based strategy of attrs, and it is a bit opinionated, but it's not too much of a problem. Just need to be aware that Pydantic will always try by default to coerce first. So coerce means that it will try to cast onto the expected type before executing the strict validation. But thanks to that, thanks to this slight opinion here, it's also a bit less verbose. So here is how you would do the same thing as I did with attrs, but with Pydantic. So same, you declare the attributes, really similar. This is like standard procedure. And you declare like the default values using the field object from Pydantic. And you can see here that there is no need for validation logic. I didn't write any this must be a string, this must be an integer. Like everything is done by for us, but big caveat, this Pydantic will try to coerce first. And I will show you an example right now. So here, same example as before. I'm passing at first like a normal expected argument, everything works well. But here you can see that the order parameter, it is 2, but 2 as a string. So it is not an integer, so technically you should expect an error race. But because Pydantic has this coerce first policy, it will first try to cast it onto an integer, and it works. So it will just execute perfectly. And this is not a problem. Sometimes you want that, actually. Let's say you serialize and deserialize from JSON, which is like essentially a string way of storing information. Sometimes you want your class to automatically cast onto the correct type. And of course, and And of course, if this is not possible, let's say here I have order that is like not int, so it's like a string that cannot be cast onto an integer, then Pydantic will raise an error. So there is this thing called validation error, which is like something from Pydantic. It just subclasses the Python exceptions, and it will raise this. And in my opinion, Pydantic is a bit more user-friendly in the way it writes the error. So what is nice is that even though Pydantic has this try to coerce first policy, you can still ensure like strict validation. So, and you do that by writing this model config within your class, and this will tell Pydantic to validate the argument in strict mode. So they will know like no coercion will be attempted. So in this example, this will work because this is an integer as expected, and this will not work. So it will raise the validation error. So you have full control on it. So both attrs and Pydantic support custom validation, and this is extremely powerful because it is a declarative way of specifying what the variable should be. So you don't write this like lengthy if-else statement in the middle of your code. You write a function, like in the case of attrs, you write a function, and there is a specific way of writing it. But essentially, look, what really matters is the value parameter here, which contains the value itself, and then you can do your validation like logic there. And then you see like here in age, maybe you want to define a user that can only be adult. You're setting, I don't know, alcohol or whatever. Then you first validate that this is an integer, and then you also validate that this is an adult. That's the way you would do it. So it is really nice because this is reusable. If you have like 35 classes that have the same kind of validation, you only define the validation once. And when another programmer is going to read your code, it's going to see this, validate is adult. First, the name is pretty clear. And then when you look at the function, it's pretty isolated, so you're like a strong separation of concern. So it's really nice and easy to understand. So Pydantic has a different approach to it, but the main idea is similar. You can also like isolate the validation, but here you would need to use a class method. So it's still within your class. So there is something I would like to emphasize here, is that the validation is really different in attrs or Pydantic, so you need to be aware of that. That in attrs, you just do the validation itself. You don't return anything special. So essentially, this will return none, and your code will continue. But like Pydantic has this validation, and when they say validation, you can actually modify the value here. So if I had value like plus equal 1, it will actually like increment my age of 1. So just a different way of doing it, but just be careful of that. But this is really, really nice because you can really like isolate that part of your code. So, attrs versus Pydantic, which one to choose? Well, this is my opinion, of course. There is nothing really like strong to be said here. But if you want a data class with a bit more oomph, I would say like attrs is your best guess at first. If you prefer like a really like a less opinionated framework that has like less thing in the back, but like that, but then you need to implement more. And something that is lightweight and fast, even though I need to specify that Pydantic, like recently, like upgraded to version 2. I think now they're like version 2.5. And Pydantic core, so all the heavy lifting is done for you in Rust. So it's really, really faster. I think there is like a times 17 compared to Pydantic version 1. So use Pydantic if you want to make use of the power of type hinting. Remember, I didn't really write validation things about types in Pydantic. Pydantic takes care of that for me. If you don't mind the under the hood mechanism, but now you're pretty much aware of like the most important part, which is the coerce first policy. So if you're aware of that, you're probably safe. And also use Pydantic if you want to join the vast ecosystem around it. So you have things like Fast API, really cool thing, and Pandera that we will talk in a moment. And also if you need to do things beyond type checking. I will speak about that at the end. But now let's see what we can do on data sets.
And you can always use both if you want. So yeah, let me just pretty briefly talk about one of the, for data science at least, cooler. Oh. Okay, yeah, that works. Right, so Pandera is a cool example of what we are talking about when we say Pydantic and Fast API ecosystem. So basically, this is a data validation library that has a specific niche, and that niche is really seamlessly working with DataFrame type objects, which obviously are pretty omnipresent these days in data science work. So this is quite nice. Starting with like a very basic example, we can see that basically we can validate data frames with schemas. Of course, it's not only data frames, but this is kind of its main use case, I would say. But series work as well, and then not just pandas, but all kinds of different data frames, Dask, you name it. You can, of course, check the types and properties of columns. You can actually synthesize data for testing with Pandera. You can do some really cool stuff that I won't go into an overview of because that would take a little too long, but you can do like statistical validation baked into your code validation using Pandera, and you can really do much more. So it's a very cool library, but we just want to briefly introduce it as an example of the ecosystem. And I'll go over a single feature of it. So that's lazy validation or soft validation. So the default behavior of Pandera is to raise the first error. So if we're going to introduce a more complicated schema and maybe we have 5 or 10 errors there, the default will be to, if we do lazy false, which again is the default, we're just going to get like the first error on this like more complicated thing. Obviously, this is not too complicated, but we're checking a few different things, and the first thing that doesn't work is going to return an error. But what we can do is we can just do the lazy validation, and this is especially useful when we want to debug, or actually it's useful in a lot of cases. And then what we're going to get instead is like a pretty nice summary of all the things that are wrong. And we can really easily analyze what's going on in this data set and why doesn't it fit the schema, right? So yeah, you can clearly see that instead of having a single error that we're not sure if it's the last one, we see every single thing. So that's it. Just an example of the cool ecosystem. And with that, we're gonna do some closing words and further discuss why the Pydantic ecosystem is so cool and why we're not exactly completely unbiased here. So Leandro, go for it.
Take this, yeah. So I talked to you about Pydantic and attrs, and I compare them for like simple validation, let's say like type validation mainly. But I have to be completely fair, like Pydantic is a bit more complete in the sense that it does more things. Of course, it comes with the cost that you will need to learn more stuff, but so it can do function validation. So attrs doesn't do that out of the box. So you can just annotate your function with the decorator validate call, and it will do exactly the same thing that for a function, than it does for classes. And you have the same kind of syntax and concept, so you can activate or deactivate strict validation. You can validate or not the return type, so it's really nice. I would really recommend to have a check. There is a great ecosystem around Pydantic. Pydantic has become like a standard in terms of like validation in the wide sense of validation, so soft and strict validation. And so we just discussed Pandera, and there is something else called Fast API. So if you've written web applications using Flask, I would really recommend that you have a look at Fast API. It does the same thing, but I would say better. It's safer, less code to write. There is validation under the hood. It's actually using Pydantic, and it's really amazing. The guy doing Fast API also did something recently with SQL stuff. I haven't had a deep look into it, but it also looks quite cool. So Pydantic has really a huge rising popularity, and I would never use that as an argument to convince you to use it, because hype doesn't mean that something is good, but it's really, from my personal experience, I would really recommend that you try, because it is a good library. And something really also important, Pydantic does JSON serialization out of the box. So that's why actually it doesn't do like strict validation by default, because sometimes you want to serialize and deserialize to JSON. And then like JSON is just a string way of storing information. So Pydantic will be able to actually convert back into the right type like this. It's a really useful thing. So, in conclusion, use type hinting to document your code. Now you have no excuse. You're aware of what it is. If you've never used it before, now you should use it. It's a really little time investment with huge returns. And you can force yourself, like, try to adopt it a bit more. And then in your team, like, make some rules. You know, no peer review, no, like, pull request story without proper type hinting, for instance. It can be something as simple as that. Like, validate your objects and functions in your code. You don't have to validate every single ones. It's useless. But if you have a pipeline with like different entry points, maybe those entry points are worth to be validated for, right? It can help you detect bugs really early on. You can really write what is expected in a declarative way. So when you communicate to your teammates, it's easier to see, to like show what you have done. And it also serves as additional documentation. So you can use attrs for that if you want supercharged data class, or if you can use Pydantic if you want the more rich ecosystem. And if you want to validate specifically data sets, like data frames and series, then you should have a look at Pandera. And Pandera also like, works really well with Pydantic. And you can make it work with attrs, but like with Pydantic, there is like a more like of a synergy between those two. And it's really useful for both data scientists and data engineers when you have like pipelines. And you can use that data validation to scan your whole data set. And with that, we are done. Thank you very much for coming today. It was a pleasure.
Yeah, we would open for some questions now. If there
Yeah,
are
we
any.
have 5 minutes for questions, so raise your hands.
Thanks for a great presentation. I have a question about reusable code with Pydantic with data classes. So inheriting with data classes can get messy. And in your example, since it's a class method, how would you make it reusable across, well, different data classes in a sense?
So Pydantic doesn't rely at all on data classes. So Pydantic uses this base. So Pydantic uses this base model, which has a completely different structure and way of working as data classes. It works with inheritance, and it will work. I mean, if you need to subclass the regressor specs class, it will work out of the box.
And can I use it with data classes out of the box, or unfortunately
You mean
not?
mixing Pydantic and data classes?
Yeah.
I mean, I don't think so, but there is no need to it. I mean, because Pydantic like does what data classes does, essentially. So just use Pydantic.
Okay.
Any more questions?
First of all, thanks for the presentation. It was a really nice overview. One more concern that I have, I work with PySpark objects a lot. Does Pydantic or attrs or any of the libraries here support working with PySpark data frames? Or Pandera, I think it was called?
Yeah, I mean, so I haven't worked with them, so I don't exactly know what is their structure. Is it like a data frame-like object?
It is, but it's a distributed.
Yeah, I mean, if the
cluster.
interface is like data frame-like.
Yeah. I mean, obviously, like, you can then check Pandera. I would say it's probably like 80% that it works with the vast majority of data frame-like objects. As, there might be something slightly more involved that you might have to do to get all the same experience, but I would assume that your use case is quite popular, so I'm pretty sure. We haven't used it for that, but I'm pretty sure it would work.
Thank you.
One more question in the end.
Hi, I have a data lake with a lot of Parquet files. We process it with pandas, data frames. Assuming I would like to add some validation to it with Pandera, is there a way to kind of load a sample data frame and introspect Pandera schema out of it? Or do I have to, define it up front and then validate it?
You mean like, so auto schema validation out of the data frame? Like you pass the data frame and Pandera like kind of like writes for you the schema, like, okay, this column is an integer, this column is a float.
Yes, something like that.
Yeah.
And then I validate all the remaining DataFrames.
Yeah, I
or
think,
Python.
yes, we haven't used it in this way, but I've looked a bit at the documentation for that at one point. And as far as I remember, yes, there is like an auto schema generation. So it can generate a base schema for you, and then you can like write on top your validation layers that you want to add.
Awesome, thanks.
Okay, it looks no more questions. So yeah, thank you one more time for your presentation.